I'm Coach Pete of Math Coach Me. I provide math coaching and tutoring services, and I also provide free lessons at my mathcoach.me site. This is the first lesson in my trigonometry series, SOHCAHTOA and the trig ratios. Unique to my approach is the use of Desmos calculators, like the one we're seeing here, to convey visually math topics and math concepts like trigonometry and sine ratios and cosine ratios. And trigonometry certainly is a very visual topic. Also unique to my approach is there is a lesson for each one of these videos. So you can go to the mathcoach.me site, you can interact with this lesson, you can interact with these calculators, and you can do things like set your own angles. So I've set this angle to 30 degrees, and you can explore, why is the sine of 30 degrees 1 over 2? And why, when I set it to 90 degrees, is it gone up to 1? Sine of 90 degrees is 1. Cos of 90 degrees is 0. And the tan of 90 degrees is undefined. Why is that? So it allows you to engage and interact with these calculators and really learn the concepts. So let's get started. Let's take a look at SOHCAHTOA and the trig ratios. The description for this video includes a link to the online version of the lesson, or you can go to the mathcoach.me site and then go to lessons, and then locate this lesson in our trigonometry series, our trigonometry 1 lesson, SOHCAHTOA and trig ratios. Trigonometry is a branch of mathematics with a focus on the angles and the side lengths of triangles. It comes from the Greek words trigonom, meaning triangle, and metron, meaning measure. There's many applications. There are applications in engineering and architecture, many applications in computer graphics. You think about that smooth motion in an animation, or if you're in a video game, that smooth rendering of those 3D spaces is also supported by trigonometry. Also in a lot of trigonometry applications in virtual reality and augmented reality for those 3D spaces that you're moving through as well. This is a aviation application that we're seeing here. So calculating the angle of descent for a plane for safe landings. The Pythagorean theorem is the most famous of all mathematical formulas and theorems. Not only is it the cornerstone of geometry, but it's also a foundational building block for trigonometry. The Pythagorean theorem states that for a right-angled triangle, the square of the length of the hypotenuse is equal to the sum of the squares of the other two sides. So for this right triangle here, where C is the length of the hypotenuse and A and B are the lengths of the other two sides, this is the algebraic version of the Pythagorean theorem. A squared plus B squared is equal to C squared. On the right, I have the first 10 Pythagorean triples. Pythagorean triples are integer numbers, positive integer numbers that satisfy the Pythagorean theorem. So 3 and 4 and 5 is the first of these. 3 squared plus 4 squared is equal to 5 squared. So that's probably the most recognizable of the Pythagorean triples. I'm going to use that one in an example of similar triangles, and I'm going to use it with two scaled versions of the same triple. The 6, 8, 10, just multiply the 3, 4, 5 by 2, and the 9, 12, 15. Similar triangles are triangles that have the same shape but may have different sizes. Let's look at the properties of similar triangles. If triangle ABC is similar to KLM, then angle A is equal to angle K, angle B is equal to angle L, and angle C is equal to angle M. Similarly, the lengths of the sides, or the ratios of the relative sides, are also equal. So the length of AB over KL is equal to the length of BC over the length of LM. And that's also equal to the length of CA over the length of MK. In this Desmos calculator, I've nested 3 right-angled triangles, and they're all Pythagorean triples. We have this purple triangle, which is a 3, 4, 5 triangle. We have this red, mostly red triangle, which is a 6, 8, 12 triangle. And then we have this green, mostly green triangle, which is a 9, 12, 15 triangle. Now, in addition to being nested right triangles, and because they are nested right triangles, they are also similar triangles. They all have a 90-degree angle. They all have a common angle at A, which means the angle at vertex B is equal to the angle at vertex D is equal to the angle at vertex F. So ABC is similar to ADE, which is similar to AFG. Now, if we compare the ratios of the height of each of our triangles to the base of each of our triangles, what we get for the purple triangle is a height of 4 divided by a base of 3, and we get this ratio, 4/3. If we compare the same ratio of the height of our red triangle, which is 8, over the base of 6, we get a ratio of 8/6, which is also 4/3. And if we compare for our green triangle the height of 12 over the base of 9, we get the same ratio, 12/9, which reduces to 4/3. So common side ratios for similar triangles, which is also one of the properties of similar triangles. But this is also the tangent ratio, and it is the first of our trigonometric ratios that we're going to talk about. So the tangent ratio is the ratio of the opposite side of the angle, and the angle in question here is at A, at the origin of our graph, right? And also, a common angle to all 3 triangles. So for the angle at A, the ratio of the length of the opposite side over the adjacent side to our angle at A is the tangent ratio. And that's equal to 4/3. And that's the same for our red triangle. Okay, so the tangent ratio for the angle at A is equal to the length of the opposite side, 8, divided by the length of the base, 8/6, 4/3, and so on. Okay, we discovered the primary trig ratio, the tangent ratio. Let's take a look at the 3 primary trig ratios, sine, cosine, and tangent. So first, take a look at this right angle triangle. We have an angle marked theta, and opposite to that angle, the opposite side of the triangle is marked as opposite. The adjacent to angle theta, this side is marked as adjacent, and hypotenuse for the hypotenuse of our right angle triangle. So for tangent, as we saw above, the tangent of angle theta is the ratio of the length of the opposite side over the adjacent side. The sine of the angle theta is the ratio of the opposite side over the hypotenuse. And the cosine of the angle theta is the ratio of the adjacent side over the hypotenuse. To remember this, there is a common mnemonic, SOHCAHTOA. And SOHCAHTOA basically identifies the first letter of our primary trig ratios, S for sine, C for cosine, and T for tangent, and the ratios for each. So for sine, it is opposite over hypotenuse, so, and for cosine, the ca is the adjacent over hypotenuse, and for tangent, it is opposite over adjacent, and we have SOHCAHTOA. You certainly want to remember that for your tests and for your exams, but it is so common that you probably won't need to write it down on a formula sheet if you need to. This is the basis of trigonometry. These 3 primary trigonometric ratios, are the basis for the other 3 ratios, the reciprocal ratios. And then those 6, are also the basis for the inverse trig ratios. So everything is based on this. So certainly an important thing to remember. SOHCAHTOA. Okay, we've come to our first activity, our first explore and learn activity using a Desmos calculator. We're going to explore the primary trig ratios, sine, cosine, and tan. And we're going to use this Desmos calculator, and there's an icon to maximize, and we will do that. And when you try this at home, when you go to the Math Coach Me site and do this yourself, and you want to do that because, certainly we're all visual learners, but we're also tactile learners. So when you're in control and you're controlling and you're asking the questions and answering the questions, that is the most effective way to learn. Visual learning, just a little point on that. Visual learning, we are all visual learners, and that's basically because there's more stuff in here to process visual information than any other sense. So also a good reason for using something like Desmos or Desmos graphics calculators to understand these concepts. So what do we have here? Well, I'm going to zoom in, zoom out. So what we have is we have a circle, okay? And this circle is of radius 5, okay? And also, what we have is we have this purple triangle, and this is a 3, 5, and that must be 4. Okay, so that's a 3, 4, 5 triangle. And we're going to come back to that, so I'm just going to turn that off for now, right? And we also have this slider to increase, up to 90 degrees and down to 0 degrees, right? I can also kind of move it around this way. So what I'm going to do first is I am going to zoom in. So we're just focusing on the first quadrant of our circle, okay? And I'm going to plug in a value, 30 degrees. That's an angle of interest that I want to take a look at. And I want to look at the trig ratios for that. And I can see the trig ratios here. So sine is 1/2 and cos is 0.86 and tan is a little over half, right? So SOHCAHTOA. So SOHCAHTOA, our sine ratio, is the opposite over the hypotenuse. Well, our hypotenuse is fixed. This is a 5 radius circle, okay? So it's always 5. Our opposite side is reflected in the coordinates for this point on the vertex, okay? So at 30 degrees, let me set it back to 30. So at 30 degrees, my opposite side is reflected in the y-coordinate for that point, 2.5. 2.5 divided by 5, the hypotenuse is 1/2. That's why we see 1/2 for our sine of theta. Now, for our cosine, the adjacent is reflected in this x-coordinate. So that's 4.33, and I can see that. That's 4.33. Well, 4.33, our cosine ratio, cosine of theta, right? 4.33 divided by 5 gives us this number, or this rational number, 0.866. And our tan ratio is opposite over adjacent, so 2.5 divided by 4.33, and that's where we get this 0.57. Okay, let's move it up. Let's go up to 45 degrees. At 45 degrees, well, we've got a bit of a special triangle. We've got a 90 and 45 degrees for theta. Well, this must be 45 as well, which means these sides are equal reflected in our coordinate pair here. Okay, so this height, or this opposite side, is 3.536. This adjacent side is 3.536. And that's why we see our sine and cosine ratio, that number divided by 5, is the same. Okay, and our tan ratio is 1. Makes sense, okay, because the opposite side is exactly equal to the adjacent side. Divide those and you get a 1. Okay, let's move it up. Okay, at 60 degrees, we can see that our sine ratio is increasing, right? And our cosine ratio is decreasing. Our cosine ratio, now it's 1/2, right? And that's because the adjacent side, 2.5 divided by 5, is 1/2. And, we can see kind of the reverse that we saw for the 30-degree angle. We can see that our sine ratio is increasing because its opposite, or the opposite side, is getting larger compared to the adjacent side. Now I'm just going to begin to drag this. And I want you to watch the sides of the opposite side and the adjacent side. So the opposite side, this side, is beginning to approach 5, okay? And when we get to 90 degrees, it's going to be right at 5. Right now we're at 4.783. The adjacent side, on the other hand, is beginning to approach 0, okay? So right now we're, let me get it to 1, just at about 1, okay? So our cosine ratio at this angle, 78 degrees, about 78 degrees, our cosine ratio is about 0.2. 1 divided by 5 is 0.2, right? Our sine ratio getting really close to 1, okay, 0.9797, right? And as I increase this, you'll see what you would expect to see, which is eventually our opposite side, now it's at 4.959, 4.977, eventually it's going to get to 5. And our sine ratio will reach its maximum of 1, okay? Once our opposite side is equal to our hypotenuse, right? On the other hand, for our cosine ratio, it is approaching 0 because this adjacent side is approaching 0. And 0 divided by 5 will be 0, right? And let me just cut to the chase and get right there. And we see that our sine ratio is at its maximum of 1 between 0 and 90 degrees, okay? And that is because the opposite side, 5, is equal to the hypotenuse. 5 divided by 5 is 1. The adjacent side, well, our cosine, our adjacent side went to 0. It approached 0, 0, 0, 0. Now it's at 0. 0 divided by 5 is 0. And tan is undefined. Okay, tan is undefined. Well, that's because the tan ratio of theta, as it approaches 90 degrees, the tan ratio is the opposite over the adjacent, and our adjacent is going to go to 0, so anything divided by 0 is undefined. Okay, same thing would happen at the other end. Okay, so as I approach 0 here, okay, as I'm approaching 0 here, my adjacent side is getting longer and longer and longer and approaching 5. My opposite side is getting shorter and shorter and shorter and approaching 0. And when I get right to 0, the opposite side is gone. Okay, and that's why sine of theta at 0 degrees is 0, because the opposite side is 0. 0 divided by 5 is 0. Cosine, on the other hand, the adjacent side is equal to the hypotenuse. 5 divided by 5 is 1. And our tan ratio is also 0 because the opposite side is 0 divided by the adjacent side, 5, is 0. Okay, let me turn this back on and let's answer that question, which is, what is the angle for our 3, 4, 5 triangle? So let's see if we can do that. Okay, so I'll try to approach this, and I'm pretty close there, okay? I can see that's almost 3 and 4, right? So I'm pretty close right now, and I'm at 53.1, okay? So it's about 53.1. Now, I've done this before. I've explored this before. So it's closer to 53.13. And I can see a 3 and 4 there, but those are actually just approximations, right? So I can see a 3 and 4 there, and my sine ratio is about 0.8, which would be 4 divided by 5. That'd be about 0.8. And my sine ratio is about 0.6, which would be 3 divided by 5, right? And my tan ratio would be 4 divided by 3, about 1 1/3, 4/3. Now, there is a function to actually determine the angle given a particular ratio. So there are a set of inverse functions, and that's part of another lesson, but let's just preview it, right? So on our calculator here, we can see our primary functions, our sine, our cosine, and tan functions. And these are the reciprocal functions. We'll talk about those in a moment in this lesson. In another lesson, we're going to talk about the inverse function. So whereas the tan ratio, when you take the tan of an angle theta, right, it returns the ratio of the opposite side over the adjacent side. Well, the inverse tan function takes a ratio. So you pass it a ratio, and it'll return the angle for that ratio. So if I were to put in the tan of 4 divided by 3, my opposite side, 4 for my purple triangle, my 3, 4, 5 triangle, I get the exact value for that angle. Let me turn that. Okay, so I get that exact value. And in fact, if I were to copy that in and set that to my angle, oh, missed it. Okay, so now it's exactly equal to 53.1 z da, 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 da. And we can see our sine ratio is this exact fraction, 4 over 5. Okay, so it is the opposite, 4 divided by 5. Our cosine ratio is exactly 3 divided by 5. And our tan ratio is exactly 4 divided by 3. Okay, let's leave that. And just want to visit here. Many of these explore and learn activities will be followed up with a practice activity, so you can try this out. You can try it on your own calculator. You can try it on your Desmos calculator. I recommend you do both, right? Try it out on both, right? Because what you'll find is it'll be a reinforcement that we are, in fact, visual learners, okay? So when you try it on your calculator, I mean, how many times have you hit the wrong numbers and calculator's confident? Hey, for the buttons you pushed, here's the answer, and you accept it, right? In fact, you made a mistake, right? But when you're doing it visually, right, you don't make those mistakes because when it doesn't make sense, it visually doesn't make sense, right? Anyway, so try it on both, right? And there are also answer keys for all of these questions as well, so you can just show and hide those as well as you're working through it. In this final section in this lesson, we're going to take a look at the reciprocal trig functions, cosecant, secant, and cotangent. So each of your primary trig functions have a reciprocal. So for sine, which is opposite over hypotenuse, its reciprocal is cosecant, which is hypotenuse over opposite. And for secant, it is the reciprocal of cosine, and where cosine is adjacent over hypotenuse, secant is hypotenuse over adjacent. And finally, for cotan. Cotan is the reciprocal for the tan function. Tan is opposite over adjacent. So for cotan, it is adjacent over opposite. So those are your 6 trig ratios, your 6 trig functions, sine, cosine, tangent, and their reciprocals, cosecant, secant, and cotangent. Basically, all of those functions, when given an angle, will return a pair of sides in a ratio format. Okay, it could be opposite over hypotenuse, hypotenuse over opposite. So in a 3-sided triangle, you have 6 possibilities, and those are your 6 trig ratios. So not to minimize it, but understanding that and understanding, getting a good grasp for the primary trig ratios and their reciprocals really is a great foundation for exploring trig. So let's take a look at in a little bit more detail using a Desmos calculator. Let's take a look at cosecant. So cosecant, the reciprocal of sine, and it is the hypotenuse over the opposite. So I'm going to go into this calculator. And the angle of interest here is 30 degrees. So right now, our circle is something called the unit circle. We're going to cover that in the next lesson. Very important topic to trig. So we have a circle of radius 1, and the hypotenuse of this triangle, which can be anywhere on this circle, right, will also be 1, right? And we'll put it back to 30 degrees. So at the sine of 30 degrees, sine of theta, our sine ratio returns 1/2, okay? And we can see that the y-coordinate of this point is 0.5. 0.5 divided by 1 is 1/2, and that looks like 1/2. That opposite side over the hypotenuse visually looks like 1/2. Now, what's a reciprocal of 1/2? Well, the reciprocal of 1/2 is 2, okay, 2 over 1. And that's what the cosecant of theta will return, okay, 2 over 1, 2. Okay, as we increase our sine ratio, as we increase our angle, we see that our sine ratio is also increasing, and that is because the opposite side is increasing in relation to the hypotenuse. And as it approaches 90 degrees, at 90 degrees, our opposite side is going to equal 1. It's going to be the same as our hypotenuse, and we get a sine of 90 degrees equal to 1. Well, the reciprocal of 1 is 1, and that's why cosecant is 1. Now, going in the opposite direction. So as we decrease our angle and our sine ratio approaches 0, okay, and that's because the opposite side is getting smaller and smaller and smaller and approaching 0, we can see that our reciprocal of that, our cosecant ratio, is getting larger and larger and larger. So the cosecant ratio is hypotenuse over the opposite. And as the opposite gets smaller and smaller, it's 1 divided by smaller, this is 0.124 and smaller, and we see that our cosecant ratio starts to take off, right? And let's go to, 1 degree, okay? And our cosecant ratio is quite large, 57, right? And if we go to, let's go to 0.1. Okay, now it's 572, right? And our sine ratio is, well, it's effectively 0, not quite there. But I can start plugging in some zeros and making this smaller still. And wow, this seems to be just a pattern here. It's increasing by 10. And so on and so on and so on. As I get right to 0, at 0, the opposite side is 0, 0 over the hypotenuse. My sine ratio is 0. On the other hand, the reciprocal of that, the hypotenuse, 1, divided by 0 is undefined. Okay, let's leave that one and continue with our next one. So the secant function is the reciprocal of the cosine function, and we have another Desmos calculator that we can use here. And the angle of interest that I'm going to start out with here is 60 degrees, okay? So the cosine of 60 degrees is 1/2, okay? Once again, we have a unit circle with a radius of 1, so any point on this circle, okay, is going to have a hypotenuse of 1 for that triangle. Let's set it back to 60. And at 60 degrees, the adjacent side is actually at 0.5. We can see that reflected here in the x value for our coordinate, right? So it's 0.5 divided by 1, and our cosine of 60 degrees is 1/2. The reciprocal of that, 2 over 1, or 2. Okay, so our secant of theta is, secant of 60 degrees is 2. As this gets larger and larger and larger, and our adjacent side is getting smaller and smaller and smaller and begins to approach 0, our cosine ratio also approaches 0, okay? So as this approaches 0, the adjacent side gets smaller and smaller and smaller, and eventually, when I get to 90 degrees, the adjacent side is 0. 0 divided by 1 is 0. The reciprocal of that, 1 divided by 0, is undefined. So our secant at 90 degrees is undefined. And there's actually an asymptote if you were to graph the secant ratio right at that point. Okay, let's move on to our last one, which is our reciprocal of the tangent function, cotangent. So For our cotangent function, it is actually adjacent over opposite, whereas tangent is opposite over adjacent, cotangent, reciprocal of that. We have another Desmos calculator to explore that. So for tangent and cotangent, our angle of interest is the 45-degree angle, and the tangent of 45 is the opposite over the adjacent side, and those sides are equal. Okay, so we can see in a 90-degree, 45, 45, these sides are going to be equal, and we can see that reflected in the coordinates in this point here. So our x value and our y value are both 0.7071, and that is why the tangent of the opposite over the adjacent is 1, and the reciprocal, the cotangent of 45 degrees, is also 1. As we approach 90 degrees, the opposite side is getting longer and longer and longer, and the adjacent side, if we look down here, is approaching 0. So our opposite side is approaching 1, our adjacent side is approaching 0, and at 90 degrees, for our tangent ratio, it is undefined, because our opposite side, which is 1, divided by the adjacent side, which is 0, is undefined. 1 divided by 0, undefined. On the other hand, for our cotangent ratio, the reciprocal of that, 0 divided by 1 is 0, okay? And you'll find the same thing happens, or I guess the opposite thing happens at the other end, okay? So when we get down to 0 degrees and our opposite side approaches 0, our adjacent side approaches 1, our tangent of the opposite over adjacent is 0 over 1, 0. The reciprocal of that, 1 divided by 0, is undefined for our cotangent of 0 degrees. Wow, we covered a lot in that first lesson on SOHCAHTOA and the trig ratios. Be sure to like this video and to follow the Math Coach Me channel here at YouTube. Also, be sure to visit the mathcoach.me site. Find this lesson, interact with these calculators. You'll really nail down and get a very good understanding for these various concepts as we work through them together. In our next lesson, we're going to take a look at the unit circle, and we can see a calculator from that next lesson here. So join me then, and let's explore the unit circle and its role in understanding trigonometry.